Now we are going to start with the first method of preparation of colloid, that is the dispersion method. That is the dispersion method. As I told you that in dispersion method, we have a particle which is bigger in size. That means it is bigger than 1000 nanometer, right? That means the diameter is just bigger than 1000 nanometer. So here we wish to have a colloidal solution of this particle, and how we can have that? We can have by breaking it into a particle that falls under the range of the colloidal particle range, right? So for this we have different methods: electrode dispersion, mechanical separation. This thing, the ultrasonic, it is not a separation, it is mechanical dispersion method, right? And the third is ultrasonic dispersion, and last is peptidization. So these are the four methods that involve the breaking of the bigger particle into a particle that falls under the range of the colloidal particles. So we are starting with the first electrode dispersion method. As the name suggests, electro means, that means electric current has to be passed, and on passing the electric current, a bigger particle breaks up into a smaller particle. So this is actually seen in the case for the metals, like metal colloidal solution. So what do we have here? We have, see, one container which contains the ice, we have the another container which contains the dispersion medium, and these are my metals made as electrode. These electrodes by means of wire is attached to a battery, and here we need a high voltage definitely. So what happens when high voltage is applied? Then what happens? This metal just gets a little bit shift towards this, and on shifting towards this, it strikes the other metal. And when two metal electrodes just strike with each other, there is a spark. There is a spark, and due to that spark, actually what happened? These metals just vaporizes, and as they form vapors, so there is a ice bath. Ice bath, and ice just condense them, and as a result they form the colloidal particles. So what actually happened, I am just repeating in a short span. Here we pass an electric current, the metal just you can say when current is passed, the metal electrode just gets shifted towards the another metal electrode, and when it gets shifted, it strikes the other metal electrode, and there is a spark there. That spark or that heat just vaporize the metal, and that vapors of the metal are just condensed back to form a colloidal particles. So that means a bigger particle breaks down to form a smaller particles, and these smaller particles somehow lie in the range of colloidal particles. So now these particles of range of colloidal particles suspended in dispersion medium. So we have a colloid here. So this is how you can prepare the colloid by electrode dispersion method. Second we have is a mechanical dispersion method, right? So what do we do in this case? First, like we have the particles which we have to dissolve in the dispersion medium. So what we will do, we will first ground these particles as fine as possible we can do. That means we will just ground those particles as fine as we can ground them, right? Then after that, these grounded particles are dissolved in a dispersion medium, and when they are dissolved in a dispersion medium, or a solvent you can say, will dissolve in a solvent, and as you will dissolve them in a solvent, we will get a suspension. We will get a suspension. Suspension means a liquid, and along with that there are particles which are not in a range of 1 nanometer to 1000 nanometer, it is somehow big in size. That is, they will form suspension. After that, as soon as this suspension is formed, we put it into a colloidal mill. This is my colloidal mill. What does it have? A two disc in which the one can rotate in a clockwise direction and other can rotate in a anti-clockwise direction. So what we are doing, we are pouring the suspension from here, and we just switch on it, and what happens, the one disc rotates in a clockwise, another in an anti-clockwise, and in doing so they further ground the particles, and after that what we get the particles that are they get broken up into a smaller particles that falls in the range of colloidal particles. So this is how we can prepare the colloidal solution by using a colloidal mill. So what you have to do first, you have to ground the particles and then put it in solvent in order to form the suspension, then pour the suspension into a colloidal mill, and because the discs are continuously rotating, and when they rotate they will just further ground the particles into a more finer particles that will fall under the range of colloidal particles. So this is what we have, the mechanical dispersion. Third is the ultrasonic dispersion. It is mostly implied for the hydrosols of mercury. Hydrosols means, hydro means dispersion medium is water, sol of mercury means dispersion having a mercury particle suspended. So what do we have here? This is my container in which I have oil and water. right? And here is my this thing. It is not water actually, it is only oil. And here what I have in this, I have the particles, a suspension of water, my dispersion medium, that is water, and I have a mercury particles. These the dispersed phase and dispersion medium do not fall under the range of colloidal particle, so we need to ground them further. So how we are doing it? We have the vibrator here, we have the vibrator here, and this whole thing is called as oscillator. This machine is called as oscillator. Now when we will switch on the vibrator, it will send the vibrations. And you know that in these vibrations, the vibration that are produced by oscillator, they are actually have the frequency higher than the audible range, our audible range, that is higher than 20,000 hertz. So those frequencies pass through oil and just strike this beaker, and when it strikes the beaker, it vaporizes the mercury, which further you can say form the colloidal the particle that falls under the range of colloidal particle. So this is how that means we are here grounding the particles into finer particles by using a vibrator. Those vibrations are capable of you can say converting a bigger particles into a smaller of the colloidal range. So this is our ultrasonic dispersion method. Last dispersion method is peptization. Dispersion method is peptization. So what do we do in this case actually? We use, like we have a solution which is obviously not a colloidal solution. We will be adding a peptizing agent into it. We will be adding a peptizing agent. Suppose I have this thing, suppose my precipitate, in this the precipitate is used actually. You can say that peptization is a process of converting precipitate to a colloidal solution. So suppose I have the precipitate of silver iodide. So let us say this is my silver iodide. Now I add a peptizing agent. So let us say that my peptizing agent is can be in any electrolyte. So let us say that it is a AgCl, right? So what will happen? As it is an electrolyte, it has a tendency to break up into ions. Now this bigger particle is going to attract the particle of the peptizing agent that is common in them. So I can see that it is AgCl and this is that is AgI and that is AgCl. What is the common ion? Obviously it is the silver ion. So all silver ions will get cling here, means they will get adsorbed here on the surface, and they will further break this bigger particle into a smaller particle of range of colloidal particles. Again, what is peptization? It is a process of converting precipitate into a colloidal solution. How? It is we take a precipitate and to a precipitate we add a peptizing agent. What is a peptizing agent? It is obviously an electrolyte which has the capability to break up into ions. So that bigger particle of the means precipitate particle, which is bigger in size, is going to absorb the common ion of the peptizing agent, and when it will get surrounded by the particle of the peptizing agent, it will, those smaller particles will just break that bigger particle into smaller ones, and hence we will get the colloidal solution. So this is how we can just employ any of the method depending upon the property, like which colloid we wish to make. So we have these four methods which involve basic thing, that is the conversion of a bigger particle into the smaller particle of the colloidal range.